All right, hey class, welcome to an episode of Brand Academy. As always, my name is Brand. I'm Mr. Wynn's twin brother. And today, we'll be talking about, what the heck is this? Oh, okay, well, we're talking about chapter 8-4, okay? So we're on 8-4 part 1. I'm just going to intro that with this here. Anybody want to take a guess what this is? This is our FV flagpole, right? It's at the bowl. I think maybe some of you guys haven't been on campus yet, huh? But this is the bowl at Fountain Valley. It's our flagpoles. So we're going to do a little connection here. Whoa. Not 6 feet apart. No mass. What the heck? I'm just kidding. This picture was taken like last year. Anywho. Okay, so let's pretend I'm here. Okay, this is Asian Mr. Wynn. He's looking directly straight at the flagpole. Okay, check this out. Boom. And then there he tilts his head up to see the top of that flagpole. Wow. What type of triangle is this? Bam, it's that right triangle, okay? The most powerful shape in the world. Okay, so here's my question here, okay, guys? How can I find the height of this flagpole here? Okay, how tall is this flagpole? Okay. So it turns out, right, I'm pretty sure some of you guys could assume this, but if pretend this is exactly a 30-degree angle, then would that not make this 60 degrees? And so if I could find the distance here, then would I not be able to use our 30, 60, 90 right triangle to solve for this missing height? Okay, so that's one way to do it, right? If this is exactly a 30-degree angle in which I look up. But of course, we know in life, there's not only 30-degree angles or 60 or 45, right? This angle here could be like 23.5 degrees, right? Or 24 degrees, 26 degrees, right? So forth. So now the question is there some tool in math that allows us to solve for any type of angle in order to solve for missing sides of a right triangle? The answer is yes. Okay, it's called trigonometry. Okay, so we're going to get started with the notes here. That's a little intro of how it could be applied in real life scenarios. And actually, trigonometry, guys, is probably the most important math in geometry that you will be using for the rest of your math career. Okay, whether you're taking whatever class you're taking next year, or even in college, right? In college, you said to take some type of math classes, right? No matter what your major is, trigonometry will always be there. Okay, so please know this is a huge foundation in your math career. So make sure you guys pay attention and really try to absorb these concepts here, okay? Because they will be popping up for the rest of your math career life, okay? Okay, so trigonometry. The word trigonometry, if we break down the word here, trigon means 3 angles, right? Tri means 3. And the word gon, right? We talk about polygon, right? Poly, many angles. So this here is specifically 3 angles. And the word metron means measurement. I'll squeeze this here. Measurement. Okay. So trigonometry, you combine it together, is the study of triangle measurements, okay? Specifically the measurements of the sides. Okay, talking about the measurement of the sides. A trigonometric ratio. Okay, please say this to yourself real quick. Trigonometric. Okay, it's a big word. Okay, I know once you're on your 3rd date, you might stutter this word, but practice it, you know, so when you go on a date with your significant other, you can say it smoothly. Trigonometric. So a trigonometric ratio is a ratio of the lengths of 2 sides of a right triangle. Okay, A trigonometric ratio is a ratio of the lengths of two sides of a right triangle. Some things to highlight: it has to be a right triangle, okay, not just any triangle. And remember the word ratio, guys? The word ratio is just a fancy word for what F word? F-U-C, fractions, okay? It's a fancy word for fractions. So each trig ratio will be abbreviated into 3 letters. Okay, so here are your 3 trig ratios: sine, cosine, tangent. Okay, please don't say sin. This is not sin, cosine. This is sine, cosine, tangent. When you do abbreviate it though, just for shorthand, this is sine, that is cosine, this is tangent. Okay, so these here, they are just specific ratios. Okay, we'll talk about these ratios shortly here. All right, and just to clarify on just some math kind of verbiage here. When I say opposite, there's gonna be 3 terms not 3 terms, but 3 words we use a lot. Opposite, adjacent, hypotenuse. Hypotenuse, okay? So if I'm focusing on angle A here, if I say the word opposite, okay, what side is opposite angle A? So it has to be this side, that's opposites, okay? The word adjacent again means next to, okay? So what's next to angle A? Well, you have 2 choices, C or B is adjacent to angle A, but it's pretty obvious that C is the hypotenuse, right? Again, hypotenuse is opposite the 90 degrees, thus making side B there your adjacent, okay? So just some breakdowns on how we name certain sides in regards to your angle. Okay, that's angle A. So below, you will write your trig ratios for a triangle. Label your triangle according to the angle whose trig functions you are finding. If you change the angle, the opposite and adjacent will also change. Okay, so specifically, read that last sentence there. If you change the angle, the opposite and adjacent will also change. So again, this is angle A. Opposite it is side A. If I use angle B for some reason, then my opposite is different. My opposite will then be B. Okay, so we got some practice here. So the sine of angle A, okay, the sine of angle A, the ratio would be opposites over hypotenuse, okay? So we find that real quick. Opposite angle A is letter A, hypotenuse is C. For cosine, it will be adjacent over hypotenuse. So adjacent would be B over C. Okay, identify that. B is adjacent over hypotenuse. And then for tangent, it would be opposite over adjacent, which would get me A over B. Okay, so pretty easy there. So now, again, it depends on the angle, okay? So now let's say I switch it to angle B. So sine of angle B, the ratio is still the same, opposite over hypotenuse. But for angle B. So for angle B, the opposite is B over C. For cosine B, okay, so cosine is adjacent over hypotenuse. So that never changes. Okay, if you use cosine, it's adjacent over hypotenuse. The thing that changes is the angle. So again, for angle B, what's adjacent? The adjacent is now side A, hypotenuse is C. Tangent is going to be opposite over adjacent, thus it will be B over A. Okay, so take a look at that. Again, these 3 names, they're just names for specific ratios. Okay, and these specific ratios are those right there, okay? What do you know about the angles A and B? Okay, here's a little question here. Look at these 2 and look at these 2. Do you see a relationship with the sine and cosine, okay? So I'm going to show you here. Check this out. Boom. Look at those 2. It turns out that sine of A is going to equal cosine of B. And then looking over here, cosine A is equal to sine B. And actually, if I want to simplify these formulas here, sine A equals cosine. Another way to get rid of this B here, because remember, both angles should equal what? Angle A and angle B should add up to 90, right? Since it's a right triangle. So technically speaking, I can just switch out angle B here for 90 minus A. Likewise over here, if I have cosine A, I can switch out sine B for 90 minus A, okay? So that's just showing a little relationship. For geometry, it's not super important. You actually probably dive deeper into this relationship in Algebra 2 Trig or pre-calculus, okay? So I'm just dipping your feet in this, okay? So know that that relationship exists. All right, right now, let me show you guys a cool acronym. Okay, so here are your 3 trigonometric ratios. So there's a super cool acronym here called SOGATOA. Okay, SOGATOA. It's not Sacagawea. Okay, SOGATOA. It's also not suck-a-toe. Some people think it's suck-a-toe, but that's kind of disgusting. I mean, if you guys are into it, you're into it. But I mean, like, you know, okay, this is just SOGATOA. Okay, SOGATOA. So this acronym is just to help you to remember the order of the sides. So for sine, right, this is opposite over hypotenuse. For cosine, this is adjacent over hypotenuse. And for tangent, this is opposite over adjacent. Okay, pretty cool acronym. Okay, SOGATOA. All right, so right now, why don't you guys do, actually, I'll do this one example here, and you guys will do this example. So find it for sine A. Okay, so again, you're working with sine A, okay? So this specific angle. Sine A would be opposite 5 over 12 for me. Wait, 5 over 12? Nope, 5 over 13. Cosine would be 12 over 13. Tangent would be 5 over 12. Okay. Why don't you guys hit pause here and do this example on your own, and then we'll come back and check. All right, guys, so please check your answers here, okay? Keep in mind, you do want to simplify your fractions when you are solving for the ratio of the sides, right? Because they're still fractions, so just simplify that. Okay, and just a little reminder how sine J and cosine L, right, they equal the same thing, and same with cosine J and sine L. Okay. All right, you guys check over to the back side of your notes. This chunk here, we will do in class on Thursday when I come back. So for now, we're just gonna skip this part. It's going over to these examples here, okay? So for these here, we're gonna be using our trig ratios with our calculators. Okay, so I'm gonna show you guys what this will look like. So let's read this here. Practice. Find x, round to the nearest hundreds if necessary. So let's look at number 1. Okay, look at the setup here. Okay, what sides were we given? And again, it's just depending on what angle you want to use. So let's just say I want to use that angle there. So my sides that I am given are the adjacent side, or just is the adjacent side. Okay, this is the adjacent side, which the adjacent side right there is 7. And the opposite side is the one that we're trying to find here. Okay, that's the opposite. So my opposite side equals x. Okay, so what would my equation look like here if I set it up? You want to ask yourself, which trig ratios will I be using? SOGATOA. So which one involves opposite and adjacent? It has to be the TOA. Okay. So you're going to use, in this case, you'll be using tangent. What angle? 36 equals x over 7, right? And the x over 7, because that is your opposite is x, adjacent is 7. So now we're trying to solve for x, right? So to solve for x here, what we need to do is to get x by itself. So we want to multiply both sides by 7. So now my equation is 7 times tangent 36 equals x. So it turns out here, okay, this is very, very important, guys, okay? Look at this. Everyone, please look. This is not multiplying tan times 36, okay? You are not doing that. Tangent 36 here, guys, this here is an actual number. Okay, so tan 36 is a number. Okay, so don't get mixed up. That is just one number right there, okay? And actually, you put this in your calculator. So let me show you guys here. Oops. Where's my tangent? So if I do 36 and hit tangent, tangent 36 is actually 0.727. Okay, let's round it to the nearest thousands. So again, tangent 36, to use your calculators, if you're using your iPhone or Samsung, you would type in the angle. So the angle here is 36. And then you just hit tangent, okay, to get that. So that's tangent 36. And what do I times it by? I should be timesing it by 7. So this here, x, this side, would be 5.0. Rounded to nearest hundreds would be 9. Okay, approximately. So that right there is what x would equal, okay? A couple things here, okay? So I want to talk about the calculators real quick. On your calculators, there's 3 different modes. Okay, these modes are basically like units. Okay, there's degrees, radians, gradients. Think of these units as in like, pretend you had inches, feet, miles, yards. Okay, so in regards to the math world itself, there's different units for different things: degrees, radians, gradients. Okay, for our class specifically, we'll be dealing with degrees. So I just want to make sure, if you look at my calculator here, I don't know, it's kind of hard to see, but look at that corner. Look at that corner of my calculator. You see how it's DEG. So anytime you're doing these problems, you want to make sure you're in degrees. So there's degrees and there's radians. Okay, you guys see how it switched there? So make sure it's on degrees, okay? Now on your actual calculator as well, take a look here. Let me go in my camera mode. I hope it's recording. I think it's recording. Okay, so you guys look here. There's sine, cosine, tangent for my calculator, so make sure you find that on yours. You will need a scientific calculator in general just to do your math on it. So if you don't have one, please purchase one sometime in the near future. Okay, having your own calculator, I do suggest Casio. It's kind of a nice one. Okay, but any calculator works. Okay, as long as it's a scientific calculator. So one thing I want to emphasize for my calculator, do you see that D there? That's for degrees. So sometimes you gotta hit shift and hit setup to make sure you're always in degrees. Okay, so DEG, I'll hit the number 3 to make sure I'm in degrees. Okay, so there's one thing I really want to emphasize. And some calculators have different orders. So for this one, I actually hit tangent first. All right, so tangent 36. Oops, delete. Boom. Okay, so sometimes you hit tangent first on some calculators. For iPhones, if you use that calculator, you have to hit the angles first. Okay, so you can do this times 7, right, from the problem before. Boom. Okay, and that's how that works. Keep in mind to put that parentheses there. Okay, because if it's not there, right? It's not going to be the same answer. So tangent 36, don't just do times 7, because that means that's part of the angle. So you're going to make sure you close it with the parentheses times 7, okay? That's why on my iPhone you saw it at 7 first, like 7 times tangent 36. That works as well, okay? So hopefully, if you guys are having trouble with this, please talk to your classmates. Obviously, if you're on Zoom, maybe call a friend and make sure you guys are able to understand how to use your calculators, okay? But that is very important. All right, so why don't you guys try 2 and 3 on your own, okay? See what side is given. What side are you trying to find? Pick the right trig ratios and then solve for it, okay? So please do that right now. All right, guys, so please check your answers here, 13.47 and 3.11. Okay, again, seeing what side you need to find. So opposite, 12, hypotenuse is x is what you're trying to find. This is your setup. So fun fact here, fun fact. Okay, if you want to get rid of this x here, right? Or sorry, if you're trying to solve for this x, something you could have done is here, which I multiply both sides by x, right? These cancel out, so then I have x in that. And then to get rid of the sine 63, you simply divide it by sine 63. Because again, this is a number, right? Pretend you had like x times 4, right? 4x, x times 4, you still divide by 4 to get rid of it. In this case, you divide by sine 63. And to put this in your calculator, I can just show you real quick. You can do 12 divided by, I'm going to hit 63 sine first, and then hit equals 13.47, okay? One shortcut, just so you know, is that when you have a proportion like that, if you have like sine 63 equals 12x, you can always just switch any fractions diagonally, right? So I can literally just switch it diagonally. This is now x equals 12 over sine 63, okay? Like if I had tangent 3 or something, and this is like 14 over w, you literally can always switch them diagonally. So now it's w equals 14 over tan 3. Okay, just a little shortcut for math, okay, for your proportions. And then here's your answer for number 3, okay? All right, good luck with your homework. If you're still confused with this lesson, I apologize. Maybe check the other website we don't talk about, Khan Academy. You can just type in trig ratios to get extra assistance, okay? If anything, just do your best, and we'll go over your homework on Thursday.